Okay, so one thing I forget to mention is that your exponential functions, if you graph them, you can have it look like this if the base is greater than 1, or it's going to look like this if the base is between 0 and 1. And then your logarithmic functions, they look like this if the base is greater than 1. And they look like this if it's between 0 and 1. Okay, I'm trying to think. Okay, but anyway, what I want to say is all of these functions, these are all one-to-one functions. Okay, and because of that, you can find inverses. And anyway, we're going to talk about this idea of a one-to-one property. Well, we had a similar idea when we were working with the exponential functions. And we said, if you have the base to some m, and it equals the base to some n, and those bases are the same, well, then you can pop out those exponents and say m equals n. You don't need the bases. You can just say, oh, m equals n. Okay, so the same idea with logarithms. So if you have a log base b of m, and that equals the log base b of n, then you can just take those arguments and set them equal to each other. M equals n. So again, you're like popping them out. You're not dividing both sides by anything. You're not adding both sides, adding to both sides, or you're not squaring both sides or anything. You're just popping out those arguments and setting them equal to each other. Okay. Now, on your paper, it should look better. On mine, there wasn't an addition sign here, and it makes a big difference. So that's why mine looks a little goofy, but yours should be okay on your paper. Okay. So here we have an equation that we're going to solve. Now you notice on the left there are 2 natural logs, and on the right there's 1. Well, in order to use the property that we just went over, we can only have 1 logarithm on each side. Okay, so we can condense these. So we're going to use property 6. Prop number 6. I should just put number 6. It's subtraction, right? So property number 6 says if you have log base b of m minus log base b of n, that equals log base b of m divided by n. So we're going to go to division here. So when we condense it, we're going to have the natural log of x plus 2 over 4x plus 3. And that's going to equal the natural log of 1 over x. They're both natural logs, so great. That means we can pop out those arguments. So we can say x plus 2 over 4x plus 3 equals 1 over x. This is great. We can solve this. This is a proportion. Yay. So we love solving proportions. We can just cross multiply. So we get to review some of our skills for solving equations. Okay, so x plus 2 times x, or x times x plus 2. Doesn't really matter which way you write it. And then 4x plus 3 times 1. Okay, so then I want to distribute. Okay, x squared plus 2x plus equals, oopsies, equals 4x plus 3. Okay, this is a quadratic equation. So we've got to get everything on the left so we can solve it. X squared plus 2x minus 4x minus 3 equals 0. So remember, when you cross to the other side, it changes the sign. Now I simplify. Okay, and I get x squared minus 2x minus 3 equals 0. That's a quadratic equation set to 0. I can factor it, or I can use a quadratic formula. I'm going to factor because it factors x minus 3 and x plus 1. So I get 2 solutions. X equals 3, I should say possible solutions, and x equals negative 1. Okay, we have to go back and check. So what was the original problem? It was way back up there. Okay, so I'm going to see if I can rewrite it. The original problem said the natural log of x plus 2 minus the natural log of 4x plus 3 equals the natural log of 1 over x. That was the original, right? Okay, so let's see what happens if we use the 3. If I put in a 3 here, that's going to be positive, right? I'd have the natural log of 5. That's okay. And if I put in a 3 here, I'd have 4 times 3 plus 3, which is what, 15? That's okay. And then if I put in a 3 here, I have the natural log of 1/3. That's okay. So you have to just make sure that every argument is positive. And they all are. So 3, that's good. Okay, so x equals 3. But what happens if I put in -1? Well, this one's okay because I get 1. Here, 4 times -1 plus 3. Now, that's going to be a problem. Nope. So that's going to be -1, and I can't have a negative argument, so no. And it doesn't matter that this one doesn't work either, but once you get one of the arguments to be negative, you can't have that for an answer. So the answer is just x equals 3.